Okay, so we talked about adding matrices and subtracting matrices, and then we talked about scalars and how we combine those with matrices. Let's talk about matrix multiplication now. Okay, so say we take a matrix A and we multiply it by B. Well, let's go with a 2 by 2 matrix here. And I'm going to multiply it by B, also a 2 by 2 matrix. I cheated my convention here. There we go, got it back. So the way this works is a little unusual, but with a little practice you'll be working this with no problem. Is you take this first row and you operate on the first column. And the way you operate on the first column is you take A sub 1, 1, and you multiply it by B sub 1, 1. Then you add to this A sub 1, 2, the second element in the first row, and the second element in the first column, B sub 2, 1. That's our first element in our answer. Okay, then we go, this operates on this. So now you have A sub 1, 1, B sub 1, 2, plus A sub 1, 2, B sub 2, 2. Okay. Next we move on to the lower row. We do the same thing. We operate on the first column with the lower row. So A sub 2, 1 is the first element with B sub 1, 1, plus A sub 2, 2, B sub 2, 1. Then we operate on the second column with the second row. A sub 2, 1, B sub 1, 2, plus A sub 2, 2, B sub 2, 2. And of course you want to simplify this stuff. So let's do this with actual integers as elements. So A times B here, we have these two matrices multiplied by each other. So again, I'm going to take the first row, operate on the first column. So it's 2 times 3 plus 1 times 2, and then 2 times 3 again, only it's this 3, 1 times 1, plus 1 times 1. Okay, that's our first and our second element. So now we do the second row. We've got, start off with 2 times 3, and then 3 times 2, 3 times 2. It's easy to get mixed up here. Then this and this column. So finally this and this column. 2 times 3, and 3 times 1. So you need to always check this over. Hopefully I didn't make a mistake. So this is 6 plus 3, and 6 plus 1. And then down here we've got 6 plus 6, and 6 plus 3 again. So our final result is the matrix 9, 6, 12, 9. And this is actually 6 plus 1 is 7. So 9, 7, 12, 9. And, oh, I see another mistake. That's why you have to go back. 2 times 3 plus 1 times 2 is 6 plus 2. So this is 6 plus 2. So this is 8, 7, 12, 9. Okay, so since I'm doing that, something might have occurred to you that this, of course, was a 2 by 2 matrix. This was a 2 by 2 matrix. But what you need to make sure that you have is that you take an n by m matrix and multiply it by an m by n matrix, and your resultant is going to be the outside values. It's going to be an n by n. So you got to make sure that the inside match, and then your final matrix is what the outside is. That's the size of your final matrix. So this relationship has to exist, and let's look at one node is misbehaving. So let's look at a 1 by 2, for example, multiplied by a 2 by 2. Notice these two match, the 2 and the 2 match. It doesn't matter what the outside is. That's going to be the size of our new matrix. Our new matrix is just going to be a 1 by 2. So let's try it out. Suppose I have a 1 and a 6. So this is my 1 row, 2 column matrix. I'm going to multiply this by 2, 3, let's go 8 and 5. All different numbers so you can see what happens here. All different. They don't have to be different numbers. Sometimes they can be the same, but they just happen to be different numbers here. So I take my row and operate on the first column. So this is going to be a 1 by 2. So this times it, or operating on that. So it's 2 plus 48. 6 times 8 is 48. This is 1 times 2 plus 6 times 8 for our first element. And then it's 1 times 3, so this times this, and this times this, plus 6 times 5. So this equals 2 plus 48, or 50, and this equals 30 plus 3, or 33. Let's go back and double check here. And looks okay. Send me an email if you notice a mistake in any of these videos. So you always have to match the size of the matrix. So always match in multiplication your n by m with your m by n. This is a multiplication. And that cross there is not a multiplication in there. That's just indicating the size of the matrix. So for example, I don't think that's 2 periods. That's only should be 1. A 4 by 16 matrix, you could operate it on something with 16 rows and any number of columns, let's just say 2. And when I do this, so this is going to be massive, a lot of work to work out. When I would do this, I would end up with a matrix that was 4 by 2. But each of these elements would be composed of a lot of multiplications and additions. Okay, so, but you can't do this. You can't take a 16 by 4 and multiply it by a 16 by 2. You just can't do it. All right, we have the associative property for multiplication. A times B times C equals A times B times C. So that's allowed. And it kind of makes sense when you think about this. This is, say you have a 3 by 2 matrix and you multiply it by a 2 by 6 and then times a 6 by 1 matrix. So if you did it in this way, you're going to end up here with a 2 by 1, and this is a 3 by 2, and your ultimately final is going to be a 3 by 1. That's what you're going to be left with if you do this. If I do it this way, I would go 3 by 2 times 2 by 6. So we're going to do this one first. So this is going to leave us with a 3 by 6 times a 6 by 1, which is a 3 by 1. So you end up with the same result. So that's what how the associative property works. It's also a distributive property. Kind of combines addition and multiplication in distribution fashion. A times B plus C equals A times B plus A times C. I'm not going to do an example of that, but you can push one of those around if you want. But here's something. You can't do associative property for multiplication. And it's kind of apparent why you can't do that. Essentially what I'm saying is you can't take A times B and say it's equal to B times A. You can't reverse the order of multiplication. This, in general, does not work. You can think about it like this, maybe. You have a 2 by 2, and you multiply it by, say, a 2 by 3. That looks legal there. But notice it does not work if you reverse it. A 2 by 3 is not allowed 2 by 2. This is not, you can't do this. Even if the matrices are the same size. Say you have this multiplication going on. Well, it does not equal this. And let's do this and we'll see. So 1 times 5 is 5, and 2 times 7 is 14, and then 1 times 6 is 6, and 2 times 0 is 0. So here, since I'm running out of time, I went ahead and finished this for this one. Now let's do this one over here. And then you see here that you end up with 2 different results. So they're not equal, so you cannot do this.